Hi, I am Krishan Berwal. Here I want to discuss about Docker. Due to a bug in Linux container, Docker works best on the 3.8 kernel. Namespace and C group must be enabled. Let us talk about namespace. Namespace is nothing but isolate the system resources for a process or group. Okay, so in Linux, 6 different type of namespace: PID, which isolate process ID, provide the process ID to each process, Unix process. Network, which isolate the system resources associated with the networking, for example IP address, IP tables, etc. IPC, isolate certain IPC resources. UTS, isolate host name and domain name. User, isolate user and group ID space. MNT, for isolate MNT point of file system seen by group of process. Okay, check whether namespace are enabled or not. Just type this command. Let's say okay, Alexi check config. Wow, here namespace is missing. Okay, user namespace is missing, so make it enable. Add it boot config file. Type sudo gedit /boot config and then version. Okay, password just add here. Config underscore for we are using for user namespace equal to y. Save it, and now again check. Wow, right now user namespace is enabled, so it's fine. Next next is okay, yes, let's talk about C group. C group is nothing but a method to put the process into groups, put some limit over resource usage. C group can be used by multiple ways, but I am discussing the use through Linux container virtualizations. Okay, so memory C group, which restrict a group to access memory up to certain limits. For example, if a process want to access 10 MB memory, so just type this command sudo echo range, and in this file system fs inside C group, inside memory dot limit dot init byte. Let's look inside the system. Let's call sudo gedit /system inside fs, inside C group, inside memory dot limit byte. Okay, so if you can see here, this is a long range, because this is by default case. Here I am not using any group. So next, okay, next CPU. CPU is nothing, CPUs which control over CPU sharing. Let's say by default all groups have 1 to 4 shares, right? If for example a particular group wants 12 to share, so just type this command echo 512 and this file cpu.share. Let's look inside the system. Sorry, C group CPU slash cpu.share. Fine. Here 1024 by default, it's okay. Let us see other C group also. C group and let's see. Okay, there are block IO and CPU ACCT, CPU sets, device freezer and memories. All these are the control group. We can restrict our process, I mean a group, put some limits over there. So far so good. So we are now familiar with the control groups and namespace. We have let's check about kernel. Kernel is let's say about the kernel -r. The kernel version is 3.8. okay, so requirement, whatever the Docker needed, it's over. Fine. So everything's right now we are using here Linux, and these are things only for Linux, not for other operating system like Windows. Okay, so far so good. Fine. So Linux have already all these things. So now let us talk about Docker. Before installation, look over some dependency. To resolve some dependency, I am installing some I'm installing backport kernel. So first I want to update the system using advanced packaging toolkit. Update, just update. Okay, fine. Okay, so after this I want to add raring as Linux kernel image, and then header. So about the header is nothing. Installations of header to enable the packaging, to enable the packages that depend on them, like ZFS, which is nothing, just combined of FS and logical volume manage and VirtualBox guest additions. Okay, so far so good. Right now I am installing this sudo apt get install Linux image, so image minus generics minus lts minus rx. Fine. Okay, next because I am using headers, sorry, I am using 12.04, and if you are using tag 13.04, 13.10, just follow the instructions we are given here, right, and given inside here. Okay, to resolve this dependency. Okay, so next what I'm trying to do is okay, so next I'm trying to do to add Docker repository key into our local keychain. Okay, so this is our key, and we get from this key server.ubuntu.com. Fine. Next I want to add Docker repository to our apt source list, just following the instructions from installation. Sorry, Okay, and again update once, update. Okay, so fine. In case of installation, after if you are already resolved this dependency, in case of installation, if you see here, everything, each steps is same, like add the key repository key to your local chain, and add your repository, and update, and installing the Linux container Docker packages. These are same things we see here also in case of 13.04 on and onwards. Fine. So let us check. Okay, fine. So in last, I want to install sudo apt get install what you call Linux container Docker packages. Okay, so it is over. Fine, let us check to run and verify this installation is working or not, and launching a container, just checking. Oh, there is an error, something, no such file or directories, no such file is created. Okay, let's see what is going on here. Okay, so okay, we are already with this. What happened actually? Docker looks like as client server. Client is nothing, whatever we are firing the command like docker run, docker push, or docker start a container, docker stop a container, like that, done on our terminal, right? This is, we can say, this is our client mode, right? From this client mode, if you see, client is are just accessing the everything from remote APIs. So client send a request over HTTP to Docker daemon, server, where server give the appropriate response according to request. So we have here what is wrong going on? We are sending a request to server, but our server is not started yet. So let us start the server. First type sudo docker, let's first start sudo docker in daemon mode, start this server. Okay, it is running. Let's again check. Oh, again there is error. Okay, so it means something is going on. Just to check our this file, resolve.config file, etc / resolve.config. okay, so here there are only one namespace, that is called same as localhost. Add your default DNS server, the IP is 8.8.8. okay, fine. Now let's start again. It is creating server. Okay, previous instance of Docker is running. Let's remove first it, remove /var /run docker.py. now start it. Now yes, if you see here, listening for HTTP on this /var, this sock of Unix, and if we compare with this diagram here, what is that? Is take request from client over this HTTP, and open a Unix socket for to creating a new process, whatever you call container, and through this TCP. Fine. So it means actually right now server is running. So again, take a how it is working actually. Take a request from client and build a tar file of image, open a Unix socket to create a Unix process or container. So using TCP over HTTP, and run internals of container, attach logic and logging info. So create a container. Yes, so I also want to create our first container. If you see right now, it is just pulling. So move on to images. Yes, there is some dependence inside the layers, so that's why it's taking some time. So if you see here, inside /var lib /docker containers, so here no container is available. So wait for some time. We want to look here, something is going on. So if you check here also, something about sudo docker ps -a, right? Okay, so it means it is created. Container ID is this, means it's over. Yeah, yes, so here it is created. So far so good. Right now we are inside the container. Okay, so let's check right now here. Yeah, the same ID with the container for 04f something blah blah blah. Okay, so you are with your first container. So let us first complete this. Our first container is like that, and if you find your container, just go here /var /lib /docker /container. Inside you will find able to your container, and this is our you can create another container, and let's look inside the container. Just type here ls b in boot, all these directories. Okay, so far so good. Let's what is inside here. cd of, just type 4. If you see here, there are 8 files. JSON logs, something, Java, this is called this is config file, 3 configuration file and 3 relevant to host, and 1 is result. If you look inside this file, sudo gedit result.config, this is not our this is not our system result.config, this is our container. If you see here, something fine. So everything is same, but I want to show the difference between when the new container is created. Difference between two container. Let's check. Just go to sudo and cd of /var /lib /docker containers, right? Okay, so right now I'm going to create another container. Just again, yes, if you look inside the container here, containers, yes, this is another container is here, and just go inside this new container, second container, and all these files like same along with this log file along with container ID and the configuration file, host file, and result.config. Result.config is same, but some changes in this container IDs, container files. Let's say sudo gedit hosts. Okay, if you see here, and if you look the first container we already created, just edit his file, its file also, host file. Fine. If you look here, Here IP address is 0.3 and for this IP address is 2, and this is our host name, which is different from this, but local host name which is same, equal to, same in both cases. So all these things provided by namespace isolations. Fine, you can edit other config dot other things are maybe same. Okay, and log file, if you look inside, let's say just edit this 04 log file. This is maintaining whenever you logging something when you are, let's say, run a command, simple apps, run inside just echo command, right? Inside container, I am inside container, right? Let's say something Krishan. Fine. So whenever you, this is ID number is A9 something 4. So if you edit just this A9 log file, so here I just log Krishan, I write through this std out, and this is my time. So log file maintaining everything here. Fine. So far so good. Right now we are ready with our container. So okay, so what I want to describe after this inside and everything is fine. So Linux have this this Linux kernel have these capabilities like C groups, namespace, Linux container also, but what I feel that Docker people also describe is Docker is a automatic engine that deployment the applications at runtime. So Docker is nothing, just easy to use the Linux container, right? So if you look one more important thing, whenever we are creating, stopping, starting the container, that time the container is under the control of this Docker. Otherwise it's sharing the Linux kernel, so that's why it is under the control of whenever let's about this example I want to show. If you are see this, like again another command, something ls, right, ll. So right now if you see here, if you again like something, if you type again something, right, one another command, so that time nothing is going here. It means it is totally under the control of operating system. Fine. So we already know about this everything about container, how to create and all these things. Fine. So next 3 levels of resource control I want to describe a little bit the difference between VM and container. VM is nothing, just isolations by virtual machines as OS1, OS2, and inside the operating system we create isolations by OS. Some people are called it is jail, some people are called it container, whatever. Some people are just a view. Actually container is nothing but wrapping some process of Unix into a folder, that's it, and attach with whatever necessary let's say storage and other capabilities which is needed for a container to run a process. Fine. So next is flexible resource control, our group, right? Let's describe something difference between virtual machines, container and RCs. In case of performance, VM is not good. Container is very good and isolation is not good. It is not good in groups, but good in container and very good in virtualization machine, because we can separate it using the kernel, right? Here you can see this runtime flexibility is not good in case of VM, but good in container. Maintenance is also good in container. Okay, yeah. Why I am saying that virtual machine creating take more than 30 minutes? I already experienced on OpenStack to create a image of create a VM. That's why that take more than 30 minutes, right? But here if you see here, just create another container, let's say exit this container and again this, it is taking less than 30 seconds, right? So okay, the people are thinking that there is any device emulation in container. The answer is no, because here no concept of hypervisor. Yeah, some people also confusing about that. Is Docker is a hypervisor, because hypervisor is nothing but just communicating with the hardware and managing two or more VMs. So that's why. But here because same thing is done by Docker, which is accessing, taking these controlling this container. So fine, so there is no concept of device simulations. And HVX, there are two type of virtualization actually: full virtualization and para virtualization. Full virtualization is nothing just to hardware emulations in term of software. Some people are saying that if we are doing with full virtualization, so attaching motherboards and all these things we needed. But in case of para virtualization, no concept of that. But container have no device emulation. That's why container is so fast, creating just whatever is needed, just put as a folder and make a copy, and it is sharing the host kernel, so no need of this some emulations is there. So VM is a tool which needs kernel, but container sharing the host kernel. Fine, so far so good. We already seen this creating a container and these examples. Next we can discuss about this, how to create a repository like whatever I created before that, vnit/doc bearwall, how to create it and other examples, and how to make a child parent relationship between container, and how to using the hamster pattern. All these things we will see soon, right? And will Docker useful for productions? Let us see reviews for that also. Fine, so you will so soon.